Let me introduce myself. I'm Karthik. I used to work at Google. I ran my startup FutureCam for a few years. I then worked as CTO of another startup. Now I work as a consulting CTO with multiple companies. Today we are going to talk about how to handle errors effectively using FutureCam code as a reference. Right? I'll be describing principles and showing you the code that illustrates those principles. And these principles are irrespective of the platform. So even if you're not an iOS engineer, this video is relevant to you. Let's get started. Before we handle errors, we need to detect them. How do we do that? There are multiple ways. One is that an exception is thrown. Here, for example, we are trying to lock the camera. And if it cannot be locked, you get an exception and you catch it using the catch statement. This is one way in which errors are reported in the form of an exception. Another way is a nil return value, like this. You're getting the CG image representation of an image. A CG image is one of the many image formats iOS supports. So you're basically converting to that format. And if the conversion fails, it returns nil. And Swift has this guardlet, which kind of modern statically typed languages tend to have features like this. So basically, if you have a variable, if you just say this CG image equal to me dot, if you just say this, it can be null. So every time you use it, CG image dot take unretained value dot whatever, right? So every time you use this, you have to check if it is null, right? Otherwise, it won't compile, and even if it were to compile, it'll crash at runtime. So one way of doing this, which you would do in traditional languages like, let's say, Java, is if CG image equal to nil, nil or null, whatever it is, depending on your language, return. But modern statically typed languages like Swift are more strict regarding to static typing. Right? I'm not giving an opinion whether that's good or bad, but it is that way in some of these modern languages like Swift and Kotlin and so on, where this variable is an optional type or a nullable type. So this still won't compile. So that is why they have something called iflet and guardlet. So what guardlet does is in this code, it will assign it to this. If it is null, it will return. And here it is a non-nullable type. Here you don't need to worry that it's null. And the compiler will let you make such calls without having to check for null because you've already checked. So leaving aside the syntax of Swift and the guardlet feature, from the point of view of error handling, what matters here is that you got a nil return value, which is one way in which errors are reported. A third way is a code. If you see here, you're creating a buffer. This is an older C-like API. You pass a pointer to this local variable which is updated. And you get a return value, which is a bool or a whatever the data type is. I think it's an integer of some kind. CV return. Yeah, it's like a type def for a int or something. Yeah, int 32. And you have to check this return value, or you have to check whether the buffer is null. Either way, right? So point is, here the error is being reported via a return value, which can be 0 to indicate no error. So that is another way. Another way in which errors are reported is a failure callback. Here, we are using something called a video data output, which after it's initialized, keeps giving you frames from the camera one by one, right? It's like it takes a series of photos or it captures a video, but it delivers each frame of the video separately. And whenever you get a new frame, you get this callback did output. Whenever the frame was dropped because of a performance issue, we are not processing them fast enough, or the system is busy doing something else, you get this did drop function invoked. So this is one way in which an error is reported via a failure kind of callback, right? And many APIs have this. They have a success callback, they have a failure callback. Sometimes we have to proactively check. So here, a device represents a physical camera, like the wide angle camera or the front camera or any of these. Now, when you ask the camera which device is active, like which physical camera are we using currently, it checks all of them. Are you using tele? Are you using ultra wide? Are you using front or wide? In this case, we have to explicitly check that if none of these is active, that wide is active. Otherwise, we give an error saying no camera found in session. So, this is an error state where none of the cameras is active. This shouldn't happen, but we have to check for it in this case. So, these are the ways in which errors are detected. An exception is thrown, a function returns nil, a function returns a false error code, a failure callback is invoked, or we have to proactively check. These are the ways in which you come to know of an error, which is the first part of the story. The second part of the story is what do you do once you detect an error? One thing you can do is tell the user that an error happened. Here, if the user has denied permission to use camera or photos, we prompt him with this alert box. So this is one way in which errors are handled by telling the user that an error happened. And in this case, when the user clicks OK, it opens iOS permission settings page so that the user can change it. In this case, the user can act on it. Sometimes an error message is merely informative. It doesn't help you solve the problem. It tells you there's a problem, you have to solve it yourself. For example, if you're recording a video and the phone is out of space, the app can't delete some of your data for you, right? It won't know what to delete. It can only tell you to free up some space and try again. So one way of responding to an error is to just tell the user that the error happened. A second way is to log it to the server. This is what I was looking for. Sorry. So when you start writing, you get a success response. And if the success response is not true, then this verify statement, it's basically a wrapper over something that logs it to the server. And on the server side, we aggregate all of these errors to find out which ones are happening more. And we aggregate them by the string. So if the couldn't start writing error has happened 10,000 times in the last month, and cannot add input has happened only once, then you know that as an engineer, you should focus on fixing this problem first. So this is important in any app. Any error that happens, you should log it to the server. It doesn't matter if it's a programmer error or more of a user error type thing. So for example, sometimes we think about, is it a programming error? So suppose you allowed the user to get into a state where none of the cameras are active, not the front or the back or the wide angle or the telephoto. That's clearly a programming error. But sometimes it's not a programming error, like the phone running out of space when recording a video. There's nothing you can do as a programmer to prevent that from happening. But I don't think this classification is very helpful because whether it is your error or not, you want to track them so that you can do something about them. For example, if the phone is out of space, you want to, just one second, you may want to tell the user before recording a video, check if there's at least 1 GB of free space available. If not, put up a prompt saying low storage. And you can make it unintrusive. Instead of like a dialog box I have to dismiss, you can show an overlay in red color on top of the viewfinder at the corner. Or you can make it blink. You can make it intrusive or unintrusive. But all these UX details aside, if you know that something is happening often, you can help the user prevent it. It's not your fault if the phone is out of storage, but it's your problem as an app developer, right? Because if someone is unable to use your app, it's a problem. So instead of trying to classify saying is it a programmer error or not, just log all of them to the server. So either you show a prompt to the user or you log it to the server or both. But you should never ignore an error. Some human being should see the error. That human being can be the user or it can be the developers. But don't just push it under the carpet, sweep it under the carpet. You can pass along an error to another function that will handle it. You don't need to handle it in the same function. Here, for example, when you invoke this function, you can get an error object in the callback. And this function invokes another function giving it the error object. That's also a valid way of handling it. You don't need to handle it yourself. And we are talking about detecting an error and handling it. But we are not talking about recovering from errors. That's very hard because your app could have gotten into a bad state. And these are not cases that happen often. They are not tested well enough. You don't even understand well enough. That's why you have an error, right? In the first place. If you understood it perfectly, your program would never have bugs. So error recovery is very hard. And in FutureCam, and by the way, this is the FutureCam website. It's an interactive website. If you don't know what it is, you can play with it, drag these sliders. So in FutureCam, I did not even aim for error recovery. Once an error happens, all bets are off. I tackled the problem upstream by tracking how often errors are happening and fixing them. Right? In the rare case when an error happens, if the app crashes, it crashes. Or if it doesn't work properly and the user has to restart it, that's also okay. Don't work around errors. This class analytics data requires a device's orientation, which should have been initialized. This is like portrait, landscape, etc. There's an initialization process that needs to be done. And it checks if the process is not done, the current orientation is reported as unknown. In that case, we again generate an error. Don't work around this. Don't assume that if it is unknown, it must be landscape. Because now you're hiding a problem elsewhere in your app rather than fixing it. So, people talk about defensive programming. You should check that the other classes are working properly, but you shouldn't cover up their mistakes. Make the mistake prominent so that we can fix it. The best error handling is error prevention. So for example, if you take user defaults where we track the number of time lapses taken, we have an increment function. Like whenever a time lapse is taken, this function is invoked and it increments this. Other functionality, like setting the count to a random number. And by the way, this count is stored persistently. And the user gets 10 free time lapses, after which he has to pay. So that's the purpose of this. And we also use it for analytics to find out how thoroughly or how extensively users are using the app. Are they just using it once and leaving it, or are they using it regularly and taking a lot of time lapses? So the number of time lapses taken can only increment. It can't increase by 3 at once, right? It has to increase by 1 each time. You can't reset it to a random value. You can never make it decrease. These are the constraints that we have for this variable. To enforce this, only the increment functionality is exposed. There isn't a setter that's exposed. There isn't a decrement functionality. There isn't an increment by n functionality that is exposed. Other way to do it might be set time lapse count, then new count, which is a int or whatever, and then you check if new count less than current count. I mean, this is pseudocode, but you get the point. Handle error. If new count greater than current count plus 1. Again, this is an error, right? The user can never capture 2 time lapses at once, only once. So you can do all these things. But now you have made a runtime error, and someone has to worry about all of these. Whereas by not exposing the functionality to decrement it, you've prevented the error from occurring in the first place. So the best error handling is error prevention. Each function or class should detect changes happening elsewhere. So this is an example I've used in previous videos. You have different modes like video, photo, time lapse, burst, etc. And in any camera app, you can switch between modes, but you can't do it when recording. And that is enforced at the UI layer by hiding the mode selector once recording starts. So there's no way for the user to change modes. He has to first stop the recording. But there was a bug somewhere that was causing the modes to change while recording. So that is why in the change mode function, we verify that it is not recording. And again, the point is, as the CIA says, trust but verify. So every class should verify that the other classes are doing their job correctly. It's like a contract, right? Both sides verify that the other side is doing what they should be doing, like in a company situation. Similarly, don't blindly assume that the other classes are coded well. Have these checks. When an error happens, they should be attributed to either the caller or the implementation of the function itself. This is an example where the caller is at fault. This is a function where the implementation of this function itself is at fault. The purpose of this function is to return these two values, and it should generate values that meet certain requirements. It does so using a helper function, which we don't need to go into. But if the implementation of this function itself is defective, it's generating bad values. Here it is checking itself. ISO should increase only after shutter speed is at max. So if this fails, it's not a problem with the caller of the function. It's a problem with the implementation of the function. So, errors should be attributed. Are you at fault? Am I at fault? So that we know where to make the code change. And these also serve as documentation to help people use the function effectively. it shouldn't be vague where, okay, something went wrong and people make arbitrary changes. They don't know whether to make the change in the caller or the callee. So that shouldn't happen. Don't have multiple ways to represent an error like null and empty string. So for example, if you look at FutureCam has hints, which are alerts that appear as you use the app. Not alerts, actually. They kind of dismiss themselves. They're not a dialog box. And they guide you on how to use the app more effectively. For example, if you're recording a time lapse, you need to record for multiple minutes. Some users don't know what a time lapse is. They think it's a video. They stop recording in 10 seconds. So in that case, we tell them record for multiple minutes. So basically, we have written code to analyze all these cases. Analyze how the user is using the app. Is he using it in daytime? Is he using it at night? Is he using the correct settings for the time of the day? And based on that, it gives contextual hints on how to improve. So that way, you don't need to know much about photography. You can just pick up the app. Whenever you make a mistake, it tells you, keep following the hints. It will teach you what to know, what you need to know about photography. So that's what this hint system is. And you have a function show hint that shows a hint. If you want to remove the hint shown, you just invoke it with an empty string. There's no separate remove hint function. If we did, it would be redundant. Because what would happen if someone calls this with an empty string? You have to handle it some way, right? Now you have two ways of doing the same thing, which is double the potential for confusion and errors. So don't do that. Offer only one way to do something. So here, this does not take an optional string. So you can't pass null to it. Why is that? Because if you want to remove a hint, you don't need to pass null. You can pass an empty string. You don't need to have two ways again, right? So don't make things null. Similarly, if you're passing an array or a map, don't make it null. Just pass an empty array because that is one less potential for an error to happen. Errors have to be described in two ways, at the code level and at the human level. So in Java, for example, we have exceptions. And we have different exceptions for different cases, right? You have an IO exception, which is a generic one. But if you are trying to connect to a server which doesn't exist, you get a host not found exception or whatever the name is. So that is one way of representing errors and classifying them at the code level. But you also need to do it at the UI layer, and you need to map these two properly. Apple, for example, is typically bad at this. You get generic error messages that say something went wrong. Don't do that. The error message has to tell the user what went wrong and what to do to fix it. This requires you to be able to map programming language descriptions to user descriptions. And sometimes it's just a coding error, in which case you don't give details. You don't say this variable was null, right? Users don't know what variables are or null means. But in some cases, you can say the phone was out of storage. So I'll give you this example. If you're trying to record a video, if you don't have permission to record the video, you should give an error message. Suppose you have permission to use the camera but not the microphone. You're going to record a silent video. You should give a message saying that. Suppose the phone is out of space. You should give a message saying that. But suppose the code itself encountered a bug. Then the error message should just be, sorry, something went wrong. Please restart the app. So this is a way of mapping these things. And this mapping is important. Don't say, please try again later, unless trying again later helps. Otherwise, it will be annoying for the user. So for example, we have all encountered websites where we try to fill a form and it says try again later. And you come back tomorrow and the same problem happens. And then there'll be some stupid reason. Your last name is too long or something, right? Or the special characters like hash, which are actually pretty common. They're not special. And the programming is kind of buggy. And it says try again. You come back tomorrow, you type in your address again with a hash. Again, it says please try again. So don't say please try again later unless trying again later will help. So crafting the correct error message is a skill both at the UX layer and at the engineering layer to map these things appropriately. Sometimes a function can handle an error itself or pass it along to another function to handle it. Handle it locally unless you have different callers who need handling in different ways. Let's see if we can find an example. Here, when saving a photo, if you cannot access a CG image representation, this function handles the error itself by cancelling the save and logging it to the server so that we can fix it. It does not invoke the completion handler, the callback, with a bool success because there's nothing the completion handler would do anyway. Now, if you're defining an API, this is not how you should do it. You should pass success failure. But in your internal code, since you know both sides of the API contract, so to speak, you don't want unnecessary coupling where somebody is telling something else that an error happened and that person handles it in a certain way. If you can handle it directly here, just simplifies the code, reduces coupling. Good object-oriented design or good modularity in general should have low coupling because if you have two classes that are very highly coupled, they're talking to each other all the time, they're effectively one class. Now you can't use one without the other. Right? Classes should be self-contained as much as possible. But sometimes passing the error along to someone else is the right decision. And how do you handle it? Sometimes you have a true or false. Sometimes you have more detailed error information. So here you have an error object. iOS error handling is not modern. They still use error codes like C because finally all this is a wrapper over C, right? More modern languages like Java. I'm not saying Java is modern in every possible way or that Swift is backward. Each of these languages has its pros and cons. One is not absolutely better than the other, but in this regard, error handling, this is an older C-like API, which is not good. It's not convenient to work with. But in any case, irrespective of what feature your language offers, sometimes you need more detailed error information than a Boolean. A Boolean is just, did it work or not? Trying to see if I can find an error, find an example, sorry. So here, when you delete a photo, you get a callback. And there's a success parameter, which is a bool. Was it deleted or not? Here, iOS actually shows the user a verification prompt saying, do you want to delete this photo? Presumably because they don't want rogue apps going and deleting all the user's photos. So anyway, so in this case, we have represented success or failure with a boolean. Use the simplest thing possible. If this works, great. Otherwise, you need to use an error object. Again, if you're using a language that supports exception handling and where exception handling is used thoroughly, Swift supports exception handling, but typically it's not used. You catch exceptions in Swift, you don't throw them. Unlike Java, where it's idiomatic to throw exceptions. So if you're using Java, you'll probably not even use a bool, you'll just use exceptions. So anyway, think about what facilities your language offers and what's the right one. The last point I have for today is don't handle all errors. We think it's good programming, and some of us who are very good engineers, we have high standards, but at times we need to overcome them. Instead, we should track these errors, find out which ones are happening often in production and fix them, not problems faced by 1 in 10,000 users. Set up this logging infrastructure once and use it regularly. Every week or so, look at what's happening in production, fix those issues. For example, you can have parental controls that prevent the user from accessing the camera. You probably don't want to handle that in your code. Actually, in this case, it's part of the Apple guidelines, so you have to handle it. So maybe it's a wrong example. But whatever the example may be, there will be some edge cases where you don't have to handle it. It's not a good ROI. We are not here to write perfect code. We are here to balance quality with speed of execution. So more error handling is not perfect. Just make sure the errors are not being swept under the carpet. They should be reported. As long as they're being reported, they don't need to be handled because you can look at your statistics and find out which ones are actually happening and fix them. And every app has problems. On iOS, for example, you will find that apps keep crashing in the background all the time. Swiggy crashes, Gmail crashes, Slack crashes, every app crashes regularly. It happens all the time, multiple times a day. You don't see it because when you open the app again, it gets restarted. So you can see why the developers are not aiming for perfect code, right? That's a waste. Don't do that. Strike the right balance. More error handling is not always better. Anyway, I hope this video on error handling is helpful. If you would like to contribute to the discussion, I would welcome that. Leave a comment. And if you want to be notified when I post more videos of this kind, assuming you found this helpful, subscribe to the channel. And if you'd like to explore working with me to help your team with these aspects, again, there's a link in the description. Thank you.